Okay. So guys, doing this, all right, on your test review for these circuits, all right, you're either going to get a series circuit or a parallel circuit. So each of them have their own unique set of rules. You have to make sure that you are using the correct set of rules. The series circuits only have one path around from start, all right, all the way around. Parallel can have, all right, a couple different ways that the current can flow, can move around. So because of that, this one is a parallel. All right, so since this is a series, I'm labeling that as a series. This is a parallel. I'm labeling this as parallel. This is a series. I'm labeling this as a series. All right, why am I doing this? Because they each have their own set of rules. You don't want to get them confused, because that was the problem with everybody in my period 1. All right, they would do one of them and then use the same set of rules for a different one, and they were not the same type of circuit. Question?
What's the series, parallel series?
Yeah.
What is it?
Those are the type of circuits, which means they have a different set of rules that you have to follow. Okay, what is 4? Parallel or series? Parallel. What is 5? Series. And 6, good, parallel. Okay, so we're going to, I think the easiest way is to stick with one set of rules and do all of them first. So we're going to do all of the series first, all right? Which means we're going to start at number 1. So let's go to number 1. You got to make V, I, and R. How many resistors do we see? 1, 2, 3. So we're going to do quick 1, 2, 3, and then T. All right, and then make our table. Okay, on the test, guys, you will need to show your work. The work doesn't need to be crazy. You can even show it inside of your box here, right, in the boxes. So the battery symbol always goes to the total voltage. So total voltage is 12 volts. Okay, the next thing, R1 is 1 ohm. R2 is 2 ohms. R3, 3 ohms. That's all we have. So we have our series circuit. We have series set of rules. The voltages are not all the same, so we cannot just put 12 straight up. The currents will all be the same, but we don't have them yet. And we have all the R's except for the total. We don't have 2 in the same row, so we can't use the Ohm's law triangle in order to find the missing. So what do we got to do? All right, you have to get it from the rules. It's either, right, that's why we make the tables. It's either going to tell you need to use a rule, or you can use Ohm's law itself to figure it out. So in this case, we don't have 2 in any row, so we don't have 2 out of the 3 variables in the same row. We cannot use that. It has to come from the rules. All the voltages, this plus this, have to equal 12. We don't have them, so we can't subtract. Okay, all the currents are the same. We don't have them. We can't equal. But we do have all the resistors. So 1 plus 2 plus 3, red, all right, is a rule. So what's 1 plus 2 plus 3? 6, all right, so we're going to have 6 ohms here. All right, we're going to have 6 ohms here. Then we are going to move on to the next thing. Well, what is the next step? What is the next move? Correct, okay, so you have now 2 in the same row. We still can't use the other rules. We've already used the resistance one. So in blue, for the math here, okay, I'm looking for current, covering that up. It's voltage divided by resistance. So I'm going to show a quick 12 divided by 6, and I'm going to get 2 amps. All right. That little work right there, guys, is going to be enough for you, all right, on the test. That's the work that needs to get shown. All right, now what? I don't have 2 in the same row. I can't use the triangle. But once I have current, I can use the current rule for series circuit. All the currents are the same. So these are all 2. No math needed. Now I have 2 in the same row, so I go back to the triangle. I'm looking for voltage. Voltage is I times R. So this is really what you can show. Put a little X there. Equals 2 times 1 2 volts. All right, 2 times 2, 4 volts. 2 times 3, 6 volts. And if you were to add these together, 2 plus 4 is 6, 6 plus 6 is 12. That would match the current, the voltage rule. So boom, 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 all done. Okay? So the work shown, the addition sign, division, multiply, multiply, multiply. Boom, done. That's what you need on your test. Take 1 and 1. Yep. Yep. All right. So now we're moving on. We're going to skip over 2 for now because that is parallel. We are going into series. So series, again, we make a VIR table, just like we always do, VIR. Okay, how many resistors do we have? 1, 2, and 3. So we're going to make a 1, 2, 3, and then always at the end you need to make 1 for the T, for the totals. Okay, make your table. Put in everything that you have. Series, total voltage goes where? VT. R1, 1 ohm. R2 is question mark, so we got to leave that blank. R3, 2 ohms. All right, what else are we given, though? What else are we given? What is the 3 amps? That is I. Good. Now, where would it go, though? Like, it's in between 1 and 2, so do I put it at 1? Do I put it at 2? Well, here's the clue. In series, it actually is not going to matter because the current is the same everywhere. So you can put it here at the total, but we're literally, because it's a rule, the current rule, all current is the same. All right. Now, once you do that, you have 2 in the same row. To find voltage, voltage is I times R, so I'm going to do 3 times 1. Get 3 volts here. I have this one here for 2 and 3. If I multiply those 2 together, that's going to give me 6 volts. And then if I want R, if I cover up R, it is V divided by I. So 12 divided by 3 is 4 ohms. Those were all done with Ohm's law because when you have 2 in the same row, you can use this to determine the other piece. Now we're stuck at 2. Row 2. All we have is this current has got to be 3, but we don't know these. You don't have 2 in the same row, so we can't use the triangle. What does that mean? You have to go to the rules. So the rules said, all right, the rules say all the resistors have to add up to equal the total, and all the voltage drops have to add up to equal the total voltage. So basically, 1 plus blank has to equal 4. So instead of adding, what can you do? You can take the total and subtract. So that's pretty much what I'm going to do. And that's because I'm using red because of the rule. So I'm going to do 4 minus 1 minus 2, which will give me 1 ohm. Then I have 2 in the same row, so I can multiply out. 1 times 3, 3 volts. And 3 plus 3 is 6, plus 6 is 12. That adds up to equal the total. Now you could have reversed this. You could have done 12 minus 6 minus 3 and gotten 3, and then done 3 divided by 3 to figure out that this would be 1. All right. Either way, you had to do a subtraction portion in that. All right. Now we're going to move on to the next series one in this is number 5. Number 5. All right, so what do we do? VIR. And we have 1, 2, 3, and then T for our totals. All right, what do we got? 9 volts VT. R1, 100 ohms. R2, 300 ohms. R3, 50 ohms. That's all you're given, but it's series. So the resistance rule for series, add them all up, all right, you get the total. So it's red, it's a rule. I'm putting red here. Whoops, sorry. 100 plus 300 plus 50 is going to give us 450 ohms. And then I can't use the resistance rule. I don't know the current yet. So look at my rule sheet for series. All right. No, can't use those. So what does that mean? I get to use the triangle. If I'm looking for I, cover up I, it's V divided by R. So I'm going to have to do 9 divided by 450. So when we throw that into a calculator, that comes out to give us 0.02 amps. All right. Now, once you have this, all right, now what do? I don't have 2 here, so I can't use the triangle, but now you have current. So in series sets of rules, currents are all equal. So these are all going to be 0.02, and because that's a rule, I'm using the red pen. All right, now I have 2 in the same rows. So now I can go back to finding the voltages. I times R. All right, so we get a calculator. We're going to go 100 times 0.2. We get 2 volts. 0.02 times 300 kicks out 6 volts. Bless you. And 0.02 times 50 is only going to give me 1 volt. But if I add these together, 2 plus 6 is 7. Nope, is 8. Wow. 2 plus 6 plus 1 is going to give us our 9, which matches our voltage rule. All right. So that is series, guys. That is series in a nutshell. All right. That is how you do them. All right. Was that hard? No, that's definitely not difficult, right? You have the rules, which you're going to be given on the test. You have the triangle you're going to be given on the test. I've even gone as far as to put the tables and draw the tables for you already, so you can't mess that up. All right. This is to make sure, right? You have to know then basically where to put everything, when to use a rule, and when to use Ohm's law, right? If you don't know those things need to be, all right, asked by the end of class. All right. Now we're going to get into the parallel set. So we're going to go over now to number 2. How do I know what is what? Well, parallels have multiple branches that the current can go around. So here we go. We have a V, we have an I, we have an R, Mac. Thank you. All right, we got 1, 2, 3 resistors. So we're gonna have 1, 2, 3, and then a T. Voltage, current, resistance. So for this one, let's put in our given information. That step never changes no matter what. 12 volts, 12 volts. R1 is 1, R2 is 2, R3 is 3. So a lot of people are like, oh, wait a minute, this is kind of just like this. We just add them all up. Wrong. You thought wrong. All right, what is that? Huh? What do you mean I thought wrong? Well, again, your parallel rules are these ones. So in parallel, all the voltages are the same. The currents have to add up to the total. And you can't just add these resistors together. You have to, if you're going to do it that way, you have to do it like this. 1 over R1 plus 1 over R2 plus 1 over 3. I'm going to show you what I think is the easier way. If I don't have to use this equation here, I don't want it. Not that it's super difficult, it's just an extra pain in the butt. So let's start it off. What do I do in this situation? Well, I know that I'm in parallel, so all the voltages are equal. So I'm using red pen here because that's a rule. Red rule. Boom, boom, boom. 12, 12, 12. Now, what do I got? I got 2 in the same row. So what do I get to do? Use the triangle. I'm looking for I, so it's V divided by R. So I'm going to do V divided by R. 12 divided by 1. We're going to get 12. 12 divided by 2 is going to give me 6. 12 divided by 3 is going to give me 4. And then what do? I'm not sure. Well, when you have 2 missing in the same row, something has to happen from a triangle, or not from the triangle, but from one of the rules. So let me look back. So I can either now use this rule here to find the total resistance, and then divide to find IT, or I can just add up all the I's. Doing a quick addition is to me, it seems a lot nicer than doing this, right? I would say so. So red rule, I'm adding all of the currents, all right? 12 plus 6 plus 4. So 12 plus 10 is how much? 12 plus 10? Thank you. What is it? Thank you. Did you know that I had someone in my other class say the answer was 120? And I was like, what? It happened twice. I actually left. I walked out. I was like, nah, you're lying. There's no way. I thought they were playing a prank on me, capping. Nope. They were like, oh. I thought you said times. I was like, yeah, sure. All right.
I got 122.
All right. You know what? Get out. All right. Anyway, so now what do we do? Use the rule of Ohm's law. So if I'm looking for resistance, covering up R, V divided by I. So 12 divided by 22. All right, so when you throw that dog in here, so 12 divided by 22, you're going to kick out an answer of 0.5454 repeating. So I'm going to leave this as 0.545, and that is in ohms. All right. Yeah, so that is, you'd be like, wait, can it be a decimal? It can be at times. Sometimes it's a little messy. I'll at least give it bare minimum 2 decimals here, but in this case, I give it the full. Now, if you decided to go the other way, I do want to show you how that would work. So if you wound up not going this way, finding all the I's first, and you wanted to find this, then this, which whatever, okay, now there may be times where you actually need to use this. So how this would work is to find RT itself, the total resistance. You have to do 1 over each one of the resistors. So 1 divided by 1 plus 1 divided by 2 plus 1 divided by 3 equals. Now what you're going to have to do, I'm literally writing this out, how you would throw this into your calculator. Okay, this stuff is going to usually, most of the time it gives you a decimal. Sometimes it can be larger than 1, but in this case, what you would type in your calculator is this, divided by, you had to hit the second key, and then the the answer from your last calculation. So what are you saying? I'll show you here. Okay, 1 divided by 1 plus 1 divided by 2 plus 1 divided by 3. Then I have enter. I get a number. This isn't the answer. What do I have written after that? I do 1. I'm going to zoom out. Right? It says 1 divided by second, and then this button right here where it says ANS. You're going to hit that, and you should see this on your calculator. Then, okay, you're going to hit equals. And what does that come out to be? The same thing. Now, someone was like, oh, I just rounded it to 0.5 and then did 12 divided by 0.5. And they're like, the answer is 24. I was like, that's incorrect. It's not. Well, then they're like, okay, well, what if I did 0.54? It comes out to 22.2. It's closer, but the more decimals you add, 22.0. All right, I'm just showing you this. 5.4, 5.4, right? It's as close to perfect as you can be. So the more decimals in that, the better it's going to wind up working. All right, so that was our first parallel. The next parallel, I'm going to move a little bit quicker. We don't have a voltage up. Oh boy, what does that mean for us? I'll show you. Be prepared to know how to solve for all of these things. Okay, go back through our other worksheets as well, because you may experience some of those things. We have 1, 2, 3, and T. Okay, R1 is 5 ohms. R2 is 2 ohms. R3 is 10 ohms. And we don't have a voltage, but we do have IT as 5 amps. Sweet. Right, so now what do I do? Oh, crap. I don't have any of the voltages yet, so I can't use that rule. I don't know these guys, so I can't do 5 minus blank blank to find the missing. Literally, in this case, the only thing that you can do, because we don't have 2 in any other row, we can't use the triangle yet, you're going to have to use this one. You have to use the total, right? You have to use the total resistance thing. So you have to do 1 divided by 5 plus 1 divided by 2 plus 1 divided by 10 equals 1 over, right? That answer. So in your calculators, you guys should please do that just so you see it. Okay, 1 divided by 5 plus 1 divided by 2 plus 1 divided by 10. Bop. That's not the right answer. Okay, you have to do 1 divided by that. 1 divided by second answer. Enters 1.25. So that, based off of the rule, right, is going to be your total resistance. 1.25 ohms. Now, this becomes pretty easy. After that, now it becomes pretty easy. You have 2 in the same row. Use the triangle. We're looking for voltage. I times R. We throw this into the calculator. It's going to spit out 6.25. Okay, we used our triangle for that. Now, the voltage rule in parallel is that all of these dudes are the same, so 6.25. And now we have 2 in the same row, so we can literally do this divided by R, right? Covering up for I, V divided by R. This comes out to give us a 1.25 amps. 6.25 divided by 2. It's going to give us 3.125 amps when you throw that into the calculator. And this dude here as our 6.25 divided by 10, and it's going to give us a 0.625 amps. Now, double check. If these things don't add up to 5, something may have gotten wrong, but these all do, and that would be beneficial, or that agrees with the current rule in parallel that the currents should add up to our total. And finally, our last one here. Okay, now you're going to do the last one here. All right. At the end, guys, if anyone needs anything, I'll come back and we can look at it, okay? Don't freak out. We'll come back if you need to. Okay. V, I, and R. We have 1, 2, 3. And you always need a T. Okay. So parallel, what did they give us? They give us the VT, 9 volts. We got 90. We got 45. And 180. Okay, what do I do? You could do the resistance rule and find out that, and do 9 divided by that. But again, I personally try not to use that equation if I can help it. So in this case, what does that mean? I'm looking at my parallel rules. All the voltages are the same. Do I know it at one spot? I do, so they're going to be the same. 9, 9, and 9. Now, 2 in the same row. So what can I do? Use the triangle. If I'm looking for I, it's V divided by R. So blue, we're using the triangle. Ohm's law, 9 divided by 9D. Don't do it the opposite way, all right? Because it will wind up messing up your answers and will not be correct on your test. So 90 divided by 9, we're going to get 0.1 amps. 90 divided by 45 is going to give us 0.2 amps. 9 divided by 180 is going to give us 0.05 amps. And then what can we do? We could use the resistance rule, or we could use the current rule, which in parallel, I'm definitely, instead of having to do this, I'd rather do this and then use the triangle. So I'm just going to add these things together. So 0.1 plus 0.2 plus 0.05. If I add all of those guys together, that's going to give me 0.35 amps. And then I have, what do I got? Now I got everything. The only thing I'm missing is RT. So I'm going to do V divided by I. 9 divided by 0.35. And then we're going to toss that into the calculator. And we're going to kick out an answer here of 25.71. And that will be ohms. Now, if you decided to use the resistance rule to figure out that, okay, you would have had to do 1 over 90 plus 1 over 45 plus 1 over 180. All right, and then taking the inverse of that answer. But remember, to do that, you got to do the second answer. 1 divided by 90 plus 1 divided by 45 plus 1 divided by 180 equals a very tiny number. I don't know what that is, but we got to take the inverse of that. So 1 divided by that answer came out to give us what 9 divided by 0.35 was. Okay, so it works. It works. So that could be a way you could have found it as well, to find your total resistance or equivalent resistance, however it's worded.